All right, so for example number 2, I'm going to do example 2, 3, and 4 in this video. So you're going to have plenty of examples of basically just simplifying. And in example 2, 3, and 4, if you look in your textbook, I'm telling you, man, they had you do some craziness. And basically the reason why that the book has you go through a very long, tedious process of solving these kind of problems is they're really trying to show you the literal mathematics that's behind simplifying these mathematical expressions. It is nowhere near necessary to do all that work. So I'm just going to straight go into like, this is how you do this. But the textbook most definitely will go into like grouping terms and factoring stuff out, and we're just not going to be doing all that here. Okay, so this is very, very simple how this works here. I have 2x minus 9x. You could think of this problem as what's 2 minus 9. It's the same thing, right? So we know that 2 minus 9 is negative 7. Okay, but the thing is that we have 2 x's and we're going to subtract 9 x's. So really it's 2x minus 9x, which is then going to be a negative 7x. So just because we have a variable tacked on there doesn't mean that there's anything different. So those will remain the same. So this would be our answer right here. Here I have negative 4m minus 6m. Just think of this as negative 4 minus 6. Well, it's going to be negative 10, right? So this is going to be negative 10m. Okay? Right here, again, when you have a negative sign, we want to multiply this negative sign, multiply that by everything that's inside of here. If you're thinking like, well, what's the actual number here? You can think of this as being actually negative 1 in the outside. So negative 1 times a negative x is a positive 1x, and a negative 1 times a positive 3x is a negative 3x. Check out this little nerdiness. We usually, anytime that we have 1 as a coefficient means that you have a number in front of a variable. We actually in mathematics we don't write the 1 right there. It's kind of like a ghost. It's like a ghostly 1. So we're actually just going to erase that. And but when I write x, that actually means 1x. But we're not going to write them both on there. Okay. All right. So now we have a little bit more ones that are longer, but nothing too crazy what we can't handle here. So check this out. The way that we handle these ones is let's just look at the ones that have the common variables, and then those are the ones that we're going to put together. So check this out. So see how this one right here is 5y. All right, well, 5y wouldn't go with negative 3z because one's a y and one's a z. So 5y would go with a positive 6y. See how those go together. So if you add both of those together, 5y plus 6y, well, I get 11y. And so that's where that comes from. And see, I just combined those together. And then if I take negative 3z and 9z, see how they both have the same variable? Okay, so both of those are going to make, so 9z minus 3z is going to give us 6z. Now, you just can't put 11y and then 6z. That's a common error that I see in students' work. Are these being multiplied, added, subtracted, or divided? So it's a plus sign right here. 9z minus 3z is a positive 6z. So these two are then going to be added. But this would be our final answer right there. Okay. Looking at B right here. So first of all, we have some parentheses. So we're going to have to do the distributive property. So let's first do 2 times 3a, which is 6a. Then we have 2 times a negative 5b, which is negative 10b. And then let's just drop these guys down right here. So we have a plus 5c, a minus 8c. Okay, and let's just do the same thing that we did up here when we kind of like took the terms that have the same variable, and then we're going to combine those together. Okay, so we know that 6a will go with, actually none of these have a, right? So what's going to happen then is your answer is just going to be 6a, because you can't combine an a with a b or a c. Okay, and then this next guy right here is negative 10b. Well, are there any other b's? No, mijo. Well, since there's no more b's, then we're just going to drop that guy down. So then we'll just say minus 10b. So we drop that guy down, drop that guy down, and then lastly we have this guy going on, right? Bam! Those guys go together. 5c minus 8c. So we just do 5 minus 8 which is going to give us negative 3c. Okay, so notice that when we have our answer, like I can't combine 6a and 10b, or negative 10b and minus 3c, because they all have different variables. Okay, so at the very end, your final answer shouldn't have any common terms that you can combine together. And lastly, I'm going to do a few more examples here. Let's go ahead and combine terms here. So we have a negative 6p and a negative 4p and an 11p. So if I do negative 6 minus 4, that right there alone gives us a negative 10p. Okay, does that make sense there? Negative 6 minus 4p, so that's a negative 10p. So now think of this as just being negative 10. What's negative 10 plus 11? Well, it's 1, right? So it's 1p. Okay, so all those together all gave me this right here. Okay? 11p, negative 4p, and negative 6p all give me that right there. And maybe the color actually makes it look a lot nicer, so maybe I'll just do that real quick just to show that. So this guy right here, and this dude, and that guy gave us p. Okay? If you combine all those right there. All right, and then we have 5 and 6. We can just combine those and get 11. Now, just don't put, just don't put 11 though. Okay, that doesn't make sense. You don't put p and 11. Is it p plus 11 minus 11? Well, 5 plus 6 is a positive, and so it's going to be plus 11. So it's p plus 11 right there. All right, coming over here, 3 times the quantity 5kx plus 3. Okay, so check this out. This is not correct. This is not correct what I'm about to do right here, but this is a common error. Students do this. 3 times 5 is 15. 3 times k, and then they'll do 3k, and then they'll do 3 times x, and then 3x. Or the other common error, that's pretty much what normally happens. It's something like that, where students will multiply 3 times 5, 3 times k, and 3 times x. Okay, this is an error. No bueno. No. You say, well, why? I mean, I thought we're supposed to multiply everything. No. Check out the rule here. It's a times b plus c. Notice that you multiply every term, but check this out. If this actually read this like this, say if it was a times bc plus d, watch this. You would think of bc as one term. It's only one term. Because think about it. If I had 3 times 5, is 3 times 5 one term or 2 terms? Well, it's 1, right? Because 3 times 5 is 15. So the point that I'm making right now is that 5 times x, 5 times k times s is actually only one term. It's one number. So really, you're only going to do 3 times 5 and then put a kx at the end of it, because you only multiply the 3 one time. Okay, hopefully that's making sense. That's what we need to do right there. So let me just kind of get rid of all this mumbo jumbo. Alright, so let's try this again then. So we're going to do 3 times the whole thing. 3 times 5kx is 15kx. Okay, so we don't multiply it by every single one because there's not plus signs right here. And then we do 3 times 3 is positive or plus 9. Okay, last but not least, we're multiplying a quarter times 8. Okay, you can think of a quarter as like 1/4 if that kind of helps. So a quarter times 8. So if I do like 8 divided by 4, that's going to give us 2. And then a quarter times 4, that's just going to give us 1. So that means it's just going to be p right there. See if that kind of made sense. So I did 0.25 times 8. Okay. And it may make more sense to do this using a quarter. So like say if I did 1/4 times 8. Does this kind of make sense? If I did, 4 goes into 4 one time, 4 goes into 8 twice. So 1 times 2 is 2. So that's where I got the 2 from. And then right here, 1/4 times 4, well, 4 goes into 4 one time. So 1 times 1 is 1. And so that's why I did 1p. So I kind of went through that quickly, but that's where that comes from right there. Okay, but again, we don't like the 1, so I'm going to get rid of that. Minus, so this is a half times 6. Look at a half times 6. 2 goes into 6 3 times. So this right here is going to be minus 3. Okay? A half times 2. Well, again, that's a half times 2. 2 goes into 2 1 time. So that's going to give us just negative p. So watch your signs here. A negative times a positive is a negative, and a negative times a positive is a negative.